Here we go. Hey, we're all doing Coffee Compiler Club, and we're here to talk about compilers and language runtimes. But actually, right now, the last 10 minutes, we've been talking about how all of us are really bad with people's names and can't remember when somebody says, "Hey, I met you at conference X," and we're all like, "Uh-huh." And why is AA called AA? Well, one of the reasons is because I'm really bad with names. So, there's that. One of the reasons is because it comes before CC and there's no correlation whatsoever between those two. Just see Chris is like, oh, I understand now.
Yeah, A was already taken, so A was the next step.
That's correct. That's correct. And I have
Yeah,
power.
and the acronym AA definitely doesn't have any other meaning.
I'm not going to go down that path.
It's too late for some of us.
It's okay for you to put things out on the Discord that what you think it might be, and I'll probably end up picking the best one. Oh, here, Matt's in the chat going, yes, it's a good phone book replacement. Okay, fine. So let's see here. Weather update. It's raining cats and dogs, or it was all last night. There was lightning, and it being at the altitude I'm at, that means that I basically can look straight across and have the lightning be at my level. It was very entertaining. I have power. We lost it briefly last night. It came back pretty quick. We're all set for a good 2 weeks of getting stormed in, but it doesn't look like it's going to happen. Okay. So that's the storm news. All right. So somebody else's turn. You want to hear the AA thing? We go for it.
I have a question.
Yeah.
So my theory was that you start out with a bad name for the language.
Uh-huh.
And then, once it gets to say 100 users, you're like, okay, we're a big language now. We need a good name. And so you hold a naming contest. And so that's how you get a good name for the language.
What is the original name of Azul Systems? It's a Chestnut, which is the corner intersection in Santa Cruz where Gil Tene and Michael Wolf were talking about, hey, we could do this thing.
You can't name your processor company after a chestnut. You have to name it after an acorn.
It got changed. A lot of money was paid to a marketing firm for picking the word Azul. And I was like, no, guys, no, this is terrible. Fine, done. And, that name's been around for 10 years, 15 years. Seems to be okay. Fine. Maybe they were right in the end. I don't know.
So, but someone else I was talking with, they were like, oh, you can't change the name. That'll ruin all the hyperlinks and all the documentation. And so nobody will know what your new language is called.
Until we had hardware, no one knew anyhow. So yeah, Acorn, Matt said Acorn's a pretty risky name. Yeah, it worked.
Well,
I mean, I thought
we could think of it as an experiment, Alan, because you did a great job picking the worst possible name. So we're halfway there.
So any direction is up from here.
I mean, the only thing I'm not sure about is the cutoff. 100 seems like it might be too large. Maybe 20 people is a better target.
Well, that's because you're a software project. The hardware guys, the name has to change before you hand the chip to a client. So you got some time, but there's a clear, we're making a chip now, and you better have it done then.
Because I know the Perl 6 guys, for the longest time, they were called Perl 6, and now they're called Raku or something. So
what? Perl?
Yeah, but that's more because Perl 6 isn't like Perl 5. The languages are very different.
Yeah. So that's not Perl.
It's not Perl.
So there was a lot of confusion where people basically saying, hey, this is called Perl 6, but...
So I should name my language CC.
No, CC2.
It's kind of right. I mean, they made a lot of changes, but it was called Perl 6 up until about the point that they renamed and released it.
Yeah, it was called Perl 6 for 20 years or something.
And it was nothing to do with Perl?
I don't know what it originally started out as, but the Perl 6 most people knew, let's say the last 10 years, it was Perl in terms of syntax, it was equally noisy with symbols, but in terms of everything else, as far as I understand, it was a completely different thing.
Wow. Okay.
So at some point they decided to change it. I think they had a contest of some sort for the name, and or maybe it was the logo. I don't remember. But either way, Rakudo came out as the new name.
Everyone remember Bodie McBoatface? The Brits decided to have a contest for naming. Yeah.
I think John Bo's language was like that. It's like JIA or something, and he's like, whatever, names later.
Names later. Yes, right. Names later. Actually, I think I can live with AA, but we'll see how it goes. But yeah, I sweated bullets on AA, and then I was like, this is really stupid. Why is this so hard? And then I was like, fine, fuck it.
I'm fine with AA as long as all the like documentation sites say AAlang somewhere on there. So there's a thing that you can actually Google.
Yes, that is one of the major fails of Elm. Go Google Elm. Well, Elm Doc or Elm Lang works, but Elm gets you every kind of tree thing on the planet.
But we
Go
hate
is
keyword.
Go, but if you want to find any documentation about Go, you search for Go.
Yeah,
For
just
Goat?
wanted to say, yeah, the language itself is called Go, but you
Right.
have to search for GoLang to find anything.
Go Lang, yes. Did you say goat? No, you said
No.
go
Yeah, I
Lang.
think he was just dropping out for a second.
Ah, fine.
Goat would be a cool term to search for though.
All right.
But in AA, we hate keywords, so it has perhaps to be a symbol. We don't have keywords in the AA.
I should not tell you, but I just thought of a great name for language. Gloat. Greatest
Gloat.
language of all time.
Bloat.
Gloat?
Yeah.
Wait, we have one of our new folks
I thought it
here.
was-
Why not call it boilerplate if we're unpacking?
There's a good name.
Okay,
Yeah.
we're gonna name the language open brace hyphen greater than close brace after the
Yeah.
function.
And that would be a great marketing name. It's the first language that doesn't have a name. It's just symbols. It doesn't have a keywords. So
It's a language of only operator overloading.
Yes, you're close. No, there's some first-class functions in there too. And curlies. All right, Anthony, I'm going to pick on you. 10 seconds
Okay.
or less. What are you doing in life? Why are you here?
Well, right now I'm taking a break from the actual compiler because just massive refactor. I'm like, you know what? I need a week to myself, but not the language.
There you
So
go.
then I decided, let's work on an assembler.
You know, Hotspot has a baked-in assembler.
Well, I would assume. Well, I mean, I would assume that you need a baked-in assembler for like a JIT, so like of some sort, you know.
Right. No, you need a baked-in assembler for all the hand-rolled assembly code.
Yeah. Like
Instead, the JIT has a direct-to-machine code design. It's a compiler.
Yeah.
So as part of the compiler, describe all the x86 opcode encodings, and he does direct-to-machine code.
So,
sorry, go ahead.
oh, so like I was thinking about something like that for my language. I was like, well, I kind of want a compiler like Go's. Well, compiler and linker toolchain like Go's, where I can be on Linux and I can compile to Mac unlike any other language.
Are you compiling to x86s? Are you compiling to x86 and ARM?
I could do both and Go.
Okay, so that's the question is whether you have any kind of a portability framework on your back end or not.
So my theory is, well, I can build like an opcode, like a pseudo opcode thing, and then translate that to to ARM or x86, and then basically do for the libc calls, I just stub those when I create the binary, and I should just be able to transparently work.
So let me tell you what we do with Hotspot, because it has been ported to more than a dozen chips. Like the assembler has generic RISC-like ops for loads and stores and calls and adds and subtracts and da-da-da-da-da. And 2 and 3 address variations in the assembler. Specifically on x86 alone, there's the extra addressing mode hacks. But when I write a load 4-byte thing, I say load 4 in C code. So there's a macro, underbar, so it just disappears in the noise. Load 4, open close paren because it's a function call, and that jams the load 4 of the appropriate architecture into the current buffer that you're jamming bytecode encodings into. If the load 4 has an addressing mode, that's an argument passed in, and the x86 has extras of those. But everyone has a load 4 bytes,
yeah,
with 0 and sign extension, so that works on all chips.
Oh yeah, no, I've got it working somewhat for basic instructions. I still need to actually work on the
And then the other
object
piece of that
the
is,
object writer.
oh, okay, yeah,
It's
right.
just-
Oh, you're actually going to go to file. Yeah, we were JIT code, so we just
Yeah.
you
No,
just had
this
to,
is AOT, so
you had to actually go execute and you're done.
I because I want a native runtime, and it's just I'm kind of sick of having to buy 3 different computers to release code.
Well, if you go to JIT code for the different guys, unless you got a really nice VM setup, I think you need at least a minimal.
You
So
know,
Matt, the answer to your question is that the assembler does not do register allocation, and that's somewhat of a lie. There is some help in the hotspot assembler for register allocation if you ask for it nicely.
Yeah.
But for like calls where you do different things, you have magic enums for each of the different registers that vary by x86 versus whatever, and you do your own register allocation, which means you hit your own ABIs for the calls. So that's in the OS specific code. There'll be calls to each guys with different calling conventions.
Yeah, my C function calls are uniform in the bytecode, and then I just change that to the ABI of the
right, which means you do a register shuffle.
Yeah, which was a lot less fun than I thought. It was like, well, you know, oh well.
So so hotspot doesn't do the shuffle.
One question to Anthony: are you expecting to take structs as arguments or get structs back from C?
And Anthony,
if you do, make sure to take the differences between x86 and ARM into account, because some you have to pass the structs in registers, field by field, depending on the field size. In some you have to pass them by pointer. So this is something you will have to implement early on.
Yeah, I'm still trying to figure that one out. I'm also trying to figure out.
It's all easy, Anthony.
Yeah.
The CABI across ARM and x86. I mean, it's like, 3 paragraphs of text, and it's easy to understand.
3 paragraphs of text, and then
it's like 5 minutes to implement. I mean, when I built
possibly go wrong.
When I built a C++ compiler, it took me like 10 minutes. Yeah.
So I found out that I still have a library card, but my library card to my old community college still works. So I was like, oh, well, let's go in there. I wonder if they have the Intel manuals. And they do. So I went there and I found out that the Intel manuals could literally kill a man. Yeah. And
don't drop
I don't. And whoever, like, I remember when I was in college, like somebody told me, it's like, yeah, no, the Intel assembly is not too hard. You can memorize it pretty easily. And I'm like, no, you're lying. No one knows the entirety.
I went to college. Right. When I went to college, it would have been possible to memorize the Intel manual.
Yeah. You could memorize x86 in terms of 8086. Maybe 286 didn't have that many more instructions, like 12 or something. By the time you got to 386, you were screwed, because you didn't just have to know the instructions, you had to know the mappings to the memory models, and
just stop now. Okay, wait. The moderator stuff. There's a chat. Matt often posts in the chat. Just be aware that you can read the chat, because Matt may put stuff there.
But so yeah, it's been a really interesting thing. Right now I'm just writing out to just a text file because it's just simple, and I can just exec my local assembler on it, and then I plan to eventually write out the binary. But I don't feel like writing 3 different file formats writers right now. So it's been a nice little
sitting. It has its purpose. You can avoid all that, and all the differences between everyone's favorite .o formats, not even instruction sets. Oh God, and what's Aaron?
I think I know exactly which one this is.
I didn't know XKCD had one of those. That's a good one.
XKCD has everything. If it doesn't have anything, it will immediately have it.
Yeah. how target independent. Well, I don't know. I'll have to go read that, but I claim Hotspot got pretty close.
Yeah. Like Go, they somehow automated their entire tool chain, like their consuming of opcodes and all of that stuff. And I really didn't feel like reading the entirety of the Go source tree and figuring out how they did that.
Yeah, in the Azul systems, we had a file, a common shared file that was opcode encodings and opcodes that was fed into the GCC port, the hardware guys' chip designs, and the hotspot JIT. So if the hardware guys came to us and said something like, we can't make this instruction work, or the current chip you got back from the foundry, actually this instruction's broken, we could just wipe it out from the single point file, and the compiler wouldn't admit the code, either the JIT or the GCC. And just
I'm thinking about like just having a file that I can just consume and then just generate the.
Yeah, well, that would make you a compiler.
Yeah.
Yeah, exactly.
I'm thinking about adding a mode to the assembler where I can just like, oh, let's just execute you in memory because I can, and then just it's like, oh, well, then I have a
memory thing is great for quick turnaround on small debugging cases, but if you're going to go large, you actually have to like deal with the whole runtime thing. And now you're basically building a jitting system in the first place. And then that may be entertaining in its own right, but it's a different can of worms. One of the fun things that happened at Azul when we had this game going on, the first chip back, actually the even or the odd registers, one of the two sets of registers bled into the branch instruction if you predicted the wrong way, and he decided that a register was being used for branch bits or whatever. Anyhow, we ended up turning off the odd numbered registers directly in the architecture description file. So it went from a 32 register machine to a 16 register machine, and everyone was just all good with it. You know, the JIT all just picked it up, and that bit in the register encodings all was 0. And then the hardware prediction logic, which was grabbing it for jumps, would quit grabbing the wrong bit, and then was fixed in the next generation chip. But you could do a lot of things with the architecture machine file. It was very handy. One more layer of indirection to get anything done, but it was handy. Okay, now it's Levo, it's your turn. Oh, no, you're 30 minutes. You in class or something. So never mind. When you feel comfortable talking, poke me or just take your mic off and say hey, or do something in chat. It's all good. Levo in chat said he can't talk for 30 minutes. I'm assuming he's got somebody in the background he's trying to not disturb.
So a fun little anecdote about my language is originally my language was going to be named after myself.
And now it's called My Language?
No, oh no, Minerva is the name of my language. Although I like that idea, I should just call it.
You could just use your initials.
Yeah, I was going to call it AA.
Well,
and then in short order, I found out Cliff named his language AA. I'm like, well,
that's because I wanted to name it CC, but that was already taken as well. And at roughly the same time as I got named CC, so somebody took mine, so I took somebody else's. So there you go.
But that would have been fun because your compiler would have been CCC.
There were a lot of folks at Sun who were calling it that already. So that was. Then they switched to C2, and there was no correlation to Cliff Click as a 2-element and 2 C's in a row. Here it was, or something. There you go, Theodore. Teo's a good name though. That's just fine.
But
maybe. We'll see.
Yeah, we'll see. Exactly.
We'll see.
I will say it's a weird thing going from one somewhat complex project to another somewhat complex project as a break from the complex project. It's just.
Once you do an assembler, it won't be complex anymore.
Well, because it's mostly a pseudo assembly, like it's just a register based ISA. It's not hard to parse,
right?
And it's just like a 1-to-1. I'm not doing any optimizations on it.
That's what I mean. This is all nitpicky stuff. It's not rocket science, but it's darn full of nitpickies.
No. I was like, well, I was talking to one of the co-developers and he says, well, maybe you should do optimizations on your ASM. I'm like, well, no, if I'm doing optimizations at this level, I already lost.
Yeah, right. You're in the wrong place. Cameron, what did you have a earlier language of yours? Not ecstasy. So there's another programming language name, ecstasy.
Yeah.
That's programming. Oh, I remember cat.
Yeah. Kitty extension. But you know, I got the compiler and the interpreter built into almost every distribution of Linux and Unix. So beat that, Cliff.
Honestly speaking, I think esoteric languages are some of the most interesting research languages in existence. Like there's Malbolge, which what's the one language where if you're not the correct amount of not polite, like it will just halt and catch fire.
So
if you're not the correct amount of what?
You have to say like
polite.
Please in front of
but not everything. You don't want to be too polite or it'll reject it. There's another one that I saw this past week. Some guy built this two-dimensional graphing language where it's basically ASCII characters and like so dash can be used to go left or right. And then there's a, you know, the caret means go up, I guess. I don't know, like, and it's got forking. And then he actually when it runs, it actually moves the cursor around. And then there's concurrency. So the cursor, there'll be two cursors sometimes. It's like, fucking hell, who came up with this idea?
Two-dimensional. This is like Turtle.
Yeah,
I was gonna say, Turtle was a reasonable way to teach kids programming, I think.
Yeah. The basic, get them started, yeah.
If you followed the Google Summer of Code project at all?
I thought they just whacked it recently.
So they had boys were finishing the course at twice the rate of the girls who started it.
Okay.
And they replaced the Angry Birds as the turtle that was being moved around with Elsa and Anna, and the differences totally went away.
Oh, interesting.
When they let you change the cursor to a female character, the rate of females completing the course then matched males.
Interesting. Okay.
And I was just like, wow, I did not think having your choice of the gender of the turtle was important, but it turns out that's important.
You keep them motivated and the different motivations for different sexes. Yeah, fine.
Just like, oh, right, the pipeline problem is our fault.
There's a learning going on there. I don't know if it's anyone's fault, but there's a learning going on there. It was not obvious to me, that you what you just said. I would not have guessed that. But in hindsight, looking back, I can see, okay, yeah, there's something there.
I don't know. I look at the breakdown of this room and think, something's off.
So, I had 4 kids, right? And when Josh was 4 months old, 5 months old, my wife bought him like dolls because she wanted to be gender neutral in raising him. And I was like, okay, whatever. And he took one look at that doll and he could crawl by then. And he picked it up and went, put it face down on the carpet, ran it back and forth like a car, and then started charging around the room with it face down on the floor. I was like, I didn't teach him that. So there's definitely some gender baked in things. There definitely is at a very, very early age.
Yeah, for sure.
All right, fine. So maybe back to now our regularly scheduled compilers.
Should we bring our final topic from the last CCC?
Somebody's running passes. What? Which one? Oh, which one was that one?
IDEs, I believe we finish it with IDEs.
As in language servers. What should your system be able to tell you about your own code?
Only Emacs. All you VI folks are wrong.
I take offense to that.
No, we're starting.
I spent way too long turning Vim into a freaking IDE.
See, there's your problem. You're using Vim instead of Emacs.
Well, I like to actually. I like having an operating system that has a good text editor.
I like having a text editor has a good operating system baked in. Stop.
But there are things that are very convenient. Like,
I have a theory.
The ability to look at a line of code and know that it's dead because the compiler looked at it and goes, this is dead code that never gets run. And I don't know. There's times when I've been like changing a line of code and then running my test and changing the line and running my test. And I can't figure out what's going on. And then I realized the line of code was dead the whole time. I kind of want something to tell me, dude, the line you're changing is dead.
Well, language servers have actually bridged the gap between crazy people like myself who use Vim as an IDE.
And Aaron, don't use Python, for fuck's sake.
Actually, at work, the project that I may have to switch from Python to Rust. So.
But I was right.
This will be an interesting jump in a few layers
Python,
of how much the compiler tries to help me.
It was Python, wasn't it?
Wow.
Also, Yorick, I blame you for the fact that when I was talking to people, they were like, I don't understand how you understand deep things in the runtime implementation of Rust, but not the basic syntax or how car use cargo.
Why am I blamed for that?
Because the reason I understand deep internals of how Rust works and what the borrow checker is doing is because of Coffee Compiler Club.
Oh, right.
And people are like, I don't understand how you can understand deep implementation details of the borrow checker, but not how to like build the code.
Oh, yeah, something
you say that you will say it. I read it somewhere.
The same thing happens to me, like when somebody's like sends me something for jobs, like what is the JVM doing? Like, I don't know. I understand how it works a bit. Like I understand its data structure because I watch CCC all the time, and it's like, see nodes go fast there.
There you go. Hey, what time zone are you in, Anthony?
I'm EST.
EST. Okay, fine.
So by the way, it's not see if nodes goes fast, because I guarantee you, if I wrote from scratch today, see nodes implementation using all the tricks I've ever learned, Cliff's would still be faster. It's because it's not see if nodes is fast. It's Cliff.
I know how
a certain way.
I know how to make C of nodes go fast.
Yeah.
You could write slow in any language, no problem.
Yeah.
But there are some things in
Hey, I didn't say slow. I just said yours would be faster.
Okay, well, but the point is that there are other IRs I've used quite a few in my life where I could not make them go fast. There was nothing to be done to make them go fast. Whereas C of nodes, there is a nice synergy in a bunch of places that in turn lets it turn around and go fast.
I believe there is my favorite. I believe there is a contention point because Cliff was hired to make something go fast. If you try to design it go fast, well, that would be a different thing.
Wait a second. I'm gonna moderate again. Levo, you just said something, so I'm gonna.
I just said performance, my favorite thing.
Okay, I just said 10 seconds. You know, who are you? What are you doing here?
I did this the first time, but I can't remember a single thing. I just made the language Bolin and then implemented the compiler. And performance is my favorite thing.
Super fast compilation speed on Bolin. Now that's what I got out of that one. Okay,
yeah.
Wait. What time zone are you in?
Toronto. I'm in Eastern.
Eastern. Okay. Oh, Toronto or something.
Yeah.
Okay. Yeah, Canada. Fine. And you're looking for a job. I remember that come by too. No? Yes?
I'd rather work on my compiler, but who knows what's going to happen.
Uh-huh. You know, if somebody came along and offered you a compiler job that wasn't your language, would you take it?
If it paid better than my last job, which is a low bar, yes.
Let's say you were saying you were less than a grad student salary. That's pretty low bar.
Some of the places that I looked into recently just like hired like the lowest of the low, and I couldn't find any other jobs. I guess the marketplace is like full here, but yeah, it was pretty bad.
Well, are you willing to move out of Toronto?
Yes, but I heard there seems to be some barriers to moving to the US, mostly because visa. Like it would have to be like contract work.
Are you Canadian citizen?
Yeah.
Oh, I can't imagine there's any issue with you moving to the US.
I think we don't protect our northern border. Like for whatever reason, the Canadians come in and take jobs all the time. So I don't know what the difference is between Mexico and Canada, but there's some difference. It makes us paranoid about the southern border.
See, I know you can drive in whenever you want,
Yeah.
It's just a full-time employment. I think the rule is a little bit different.
I don't actually don't know. I have to go look it up. I know in the past, but that was before, pre-Trump era. Like, no, nothing. You just come to the US and work and no one cared.
I wonder what commercial compiler work is. I mean, a lot of stuff is happening in the ML space because they're like.
So Oracle hires a lot of people who do compilers for their databases.
Yeah, yeah.
So what would
If
be
you want
a
to do SQL query optimization,
Yeah.
there is serious money there.
what would be a competitive salary for a compiler engineer?
Depends on whether Oracle's hiring you to fix their database or not.
Yeah.
It depends I mean, it depends how good you are and how well known you are, and if you have a PhD from Stanford or MIT and you're a senior in school, and labs will hire you for 200. And you're not even a graduate out of college, right? So but you're the world's greatest programmer, but no one knows who you are, and you don't have a degree. A lot of companies won't even bother.
They don't know me for sure yet.
It's not fair, but it's not intelligent. It's not fair, but unfortunately, that's how it works sometimes.
Yeah, I understand.
And that was my early 20s right there. Just couldn't afford to finish college, and it's like, yeah, well, But then I found a job, and then the past couple months happened. But it's fine. I'm good.
Excellent.
I think Apple also has a pretty big team that works on LLVM, trying to make sure that it plays nice with their silicon.
Yeah, that would make a lot of sense. In times past, I was obviously Microsoft also.
Yeah.
As a strong compiler team group.
Google also has a bunch of people that work.
Huge Google. Yeah. Yep.
The issue with.
And I hear rumor there's at least one person at Facebook trying to make Python go fast.
Okay, I found it.
There were people at Facebook that tried to make PHP go fast.
Yes. Yeah, plenty of those as well. Hack.
I mean, Hack is an interesting project. It worked.
Yeah.
I pasted in the link to the video.
What video is this?
You're not gonna fucking believe it.
You're right.
That's a language.
Okay, I have a non-playing. GCC-F sanitize equals undefined. Is this what the thing you're trying to do here? Here you go.
Click the play.
I'm debating clicking it while I'm live. Is it safe? It's safe for
Yeah, you're just gonna give me all your Bitcoin. What do you want?
Oh, okay. Well, no problem. Oh, that's it. Oh my God, that's beautiful. Holy crap.
It's called Princess, and it's by Sam Worsrand. I don't know how to pronounce.
This is your 2D language?
Yeah, that's what I was telling you about. He's been posting videos of various weird.
Awesome.
I mean, it's an ESLang. It's cute.
What did it actually do? But it was fun to watch.
Bingo.
Hey, Levo's fine. Don't worry about it. And people drop all the time. I'm reading his chat. He's having audio issues. And we also have a few people who just do chat because they have audio issues all the time. They have mic issues all the time. Fine.
Okay,
that's the amazing thing about Matt, by the way, is like he's got a brain that holds every URL ever created.
Oh my God, yes, Matt.
Of
Thank you very much
engineering,
for
computer science, compilers, right?
the links.
And but he can't get a microphone to work.
Well,
I didn't say it.
I ran audio for my church and several events for years, and doesn't matter what operating system you're on, Windows, Mac, Linux, audio's the worst. You can get video working perfectly. Audio will always find a way to break.
Excellent. I see. Okay.
Yeah, that's one of the challenges I've talked about with the can you go write your own operating system? And if you set your bar at, I can read audio from the mic, I can read the mouse, I can read the keyboard, I can display a pixel on the screen. Maybe I can take a picture with a camera and I can send a packet across the network over IP. You could get that done on a Commodore 64 relatively quickly. But
Also,
to take a modern architecture and be like, oh, I'm going to get an HP server to do those 6 tasks, it could take you years to write an operating
it's pretty
system.
exciting, Aaron, because I read the Linux mailing lists, and actually, as of 2023, you can now get sound out of Linux.
Wait, what?
Yeah, actual.
Oh my God!
But it's true. I
It
wonder if our
it
hardware.
did take them 20 years to get sound working in Linux.
Jeez.
Right, but I wonder if that's a sign that our
exaggeration.
hardware metaphors are fundamentally broken. Our operating system.
What's really funny?
Why is it hard to draw a pixel to the screen?
It's not as much.
I've done pixel to screen OS things on hardware of Commodore 64 era, a couple different, both 64 and also not really Apple II, Color Computer, Radio Shack Trash 80, both. So just 3 different machines basically, and the answer was hardware mapped to a fixed known address. You just put a virtual name, a fun name for the base, and then you said base plus offset array update, and boom, you got it. Whereas these days, to get pixels on the screen, you have to go through some goddamn amazing hoops.
Yeah, and just to be clear, you wouldn't draw them on the screen. You'd draw them to a buffer that wasn't on the screen. Then you'd copy, you'd blit the buffer to the screen.
No, and the hardware of the era I was talking about, you wrote straight to the memory that was backed by the hardware to the screen. It was not a double buffered thing at all.
Hmm.
Yeah, there were a bunch of old Nintendo games where you see this crazy perimeter around the game of random colors, and you'd be like, why did they do that? And you find out later it's like, oh, they were out of memory, so they just used the memory that was the screen buffer.
Yep.
Here's some extra bits. Let me just stick game state in the perimeter and it'll look fine.
Yeah.
Yeah, if you want your mind blown, look at
all right, read the chat for Matt. It's spot on. Yes, exactly. I've been there.
Somewhat tangentially related to compilers, actually. And the Super Nintendo, we were trying to develop a link because we were really tired of having to hand roll out assembly for doing code executions on the Super Nintendo. So we're trying to find a way to just to build like a tiny language that we could use to for some of our code executions. And eventually we gave up, mainly because it was too much engineering for too little gain, and it was hard manipulating it in such a way.
Forth is the language you're looking for.
Yeah.
For a throwaway, quick put together language, you can write Forth in an afternoon and code in anger with it the next day and get shit done.
Yeah, but it's we found many of ways to abuse the Super Nintendo using Mario Brothers to just shove Twitch chat into it, shove video into it, shove audio into it.
Yeah, you were. I saw that comment go by. That was like, that looked like fun stuff.
Yeah, we actually set off an AWS alert with that one.
Excellent, excellent. All right, let's see if we can bring it back to compilers or language implementation somehow. No. I pushed to AA to master because it's gotten stale enough to do small things with primitives, but I didn't touch the REPL, so I assume the REPL's still broken. And anything beyond small things with primitives probably hits an implemented or an assert pretty quick. 5 minutes of AA update. It's definitely making progress. It's definitely being slow. Fine.
So what is your plan in AA for things like draw a pixel to the screen?
That's a lib call somewhere.
Yeah, that's not a language.
There's falls back to what is the FFI story?
Yes and no. So there's an FFI story that has to happen, right? Fine. And separately from FFI, there is wouldn't it be super nice if you got a super easy setup default screen to go draw on that just took off all the learning curve to go put bits on a screen? as a throwaway, I just want to slap a graph up. I just want to bounce a sprite around, get it done. 1980s era game with modern resolution, right? And so there's like a theory that says you said import graphics or something stupid, and there was baked in already a free canvas. It is always displayed immediately. It has standard 2D addressing with pixel bit colors and has some support for, hitboxes and cursors and all that kind of shit. And you could just start with import graph.
Yeah, it is nice to just say new canvas, this many pixels by that many pixels, and a window pops up.
And a window pops up, right? And now canvas is an array,
or whatever your operating system's way of getting a canvas on the screen pops up.
Right. And then you have an array-like API, and you say canvas of square bracket 2, 3 equals red, and red pixel appears. And then from there, you could build up all the usual things to do minor graphic shit. But the point is, get it started in 1 to 2 lines, and you can see something.
Mostly like a library problem, right? It's not really anything to do with the language.
Yeah, it's not AA, it's a library problem. But I think any language that does something that's intended to do something beyond whatever, just not special purpose, I think ought to.
Yeah, but I think it is something that's missing. I think the fact that Java had swing, and you could say, hey, I want to throw a thing on the screen, and that Python didn't. Like, there was a culture of GUI apps in Java, and there really is still not much of a culture of GUI apps in Python. And I think that's because the Python standard library didn't have a simple default, here's how you get a window open and draw something to this, draw a pixel.
Right.
Similarly, I want something that's like, here is your ring buffer that is just playing 8,000 samples per second audio. And if you stick stuff in the ring buffer, it will play until it hits the end. And if you can keep up and
keeps going, right?
Well, if you keep sticking more audio in faster than it pulls it out, then it'll keep playing audio. But if you don't keep sticking audio in faster than it reads it out, it'll hit the end and just stop.
Yeah.
Like, that's a really simple audio API to just say, put integers into a buffer, put audio on the speaker, put integers into a buffer, put pixels on the screen.
Yeah. Okay. So there you go. And well, never mind. We start designing a graphics audio API call for minimalist. No, let's not do that here. But there is a thing that says you should have a super easy lower bar for doing basic sound and graphics, and that would be attractive. Yeah, pull people in, but because it was so easy.
Well, so I don't have a solution for audio, but like I was looking at Dart, and like they have like this whole Flutter UI framework, and I was thinking you could just copy that. It's probably a good design.
I don't know what SDL2 is, Levo.
Oh, that's a simple direct media layer. It's like this library in C or C++. I forget which. I think it's C. Yeah.
Okay.
So basically, you can just it's sort of like a library for dealing with Windows systems and audio and stuff. And so basically you load the STL library, and you can just draw to the screen and make a game or something that, pretty easily. It's mostly used
what's the game engine everyone uses? I want to say Unicode. It's not the
Unity.
Unity.
Yeah.
Which has a bastardized C# in it.
There you go. Okay.
Trying to make it fast. I watched some.
Well, it's like a fork of C# from 1982.
Oh, isn't it mono?
That's something separate.
Doesn't it use the mono runtime, if I remember correctly?
It might.
Yeah,
it was original,
but it forked it so long ago. Like you still have to type in all uppercase.
It certainly was mono. I'm not sure if what the language level is though.
They forked it in the 90s. It's gonna be pretty.
Well, no, it wasn't the 90s, but it got out of date at some point really, really bad, and I don't know if they ever synced it.
Yep.
Well, it's funny because part of the reason I wanted to write my own language was because I was doing some Vulkan stuff in C++, and I got a template error. several template errors that were so bad that I had to yell at a wall for about an hour. And I was just like, no, never again. No, I just.
So
I
once got a template error.
So large that you were yelling while you're waiting for the message to scroll by?
I was going to say, I once got a template error and I published it as a book.
It's just like, but it's, the language wants you to use templates. Like there's so many things that are so useful if you can just make them generic. And it goes out of its way to punish you for trying to do that.
Yeah. Yep.
And I get, I was like, oh, well, I have this crash. Why did I crash? Okay, well, let's open this up in a debugger. Let's see the call trace. And it crashed in there. I'm like, oh, well, now I can at least read where I crashed. Well, I still don't know why, because I don't have enough runtime information.
Yeah.
I strongly dislike templates. I wrote my entire compiler using the minimum amount of templates I can. The only time I use it is I wrote a replacement for vector as my own array type, and that's the only place I have templates.
Hotspot was in the early days of C++ and using CFront actually to start with, and we had a rule that templates were limited to being square bracket array, resizable array replacements, and that was the only thing we used templates for.
I mean, honestly, my favorite feature of the preprocessor is X macros. It makes my life so much better too.
I want to use that, but I can't find a reason.
Why did Hotspot pick C++ instead of C?
Because it was the up and coming new language. And at that era, C had other things that C++ fixed. Like you had to put all of your variables at the start of a function. You couldn't define them in the middle. And in C++, you get a lot more functional because you can put your variable declaration right where you have the data necessary to initialize it.
That was fixed before Java was started.
When we
remember, he was working on Sun.
Okay, Mark.
No, that was Sun. Sun's compiler was like 40 years.
Oh, well, that I could buy.
Okay, wait, but there's another piece. We were intending to be portable, so we had to pick the lowest common denominator of C or C++ on every platform we were targeting at that time, at that era. So the lowest common denominator did not let you put the ints in the middle.
Wow.
Whatever error that was, it sucked. Yeah, there was a bunch of things sucked there.
So that was part of the side effect of Java wanted to target like VCRs and.
Oh yeah,
really
Sun's plan was to kick Microsoft and IBM around by having a portable language, and that would let them put hardware everywhere. They were going to sell their hardware anywhere, everywhere by having a language that you would just write to. That was the write once, run anywhere.
I mean, by all intents and purposes, I mean, while Sun didn't sell all the hardware, Oracle sure did kick everybody on the language front for years. With Java.
Oh, with Java. Well, Sun had management issues why they failed out. That was a different issue there.
But it also sort of worked. The YubiKeys are written in Java, and there's a JVM that runs on my security key. Like,
yes, Java chips. Yeah, they made it. Yeah. There was a bunch of things that actually got there.
But yeah, no, one of the reasons why I originally picked C++ is because I wanted a native language. Rust, I didn't really have the time. I didn't really want to use Rust as a language that I didn't know and then have to learn.
Right.
That blows my weirdness budget every time I try it.
I tried learning it, and the little I did learn, I just didn't like.
So
it's too many performance problems I noticed while trying to use it for anything.
Okay, wait, I have to comment here. Derek, you look like you're in some, 1999 Blade Runner prison cell thing.
That's exactly.
I think that's just a conference room.
Oh yeah, but it's like black and white with a little bit of color on your face, seen from far away. It's very abstract, arty.
All you need is a white cat to pet.
That's what the conference rooms look like at the Grand Budapest. I mean, what can you say?
That's right. Yeah, this is room 101. It's whatever the previous company that was in our office decorated, we just left it at that. So apparently it's a picture of Warsaw.
Okay. Okay.
You know, the Silence of the Lambs, where initially the person comes in and it's a drawing on the wall. It looks like that.
All right.
So yeah, no, I picked C++ not because, you know, I really am in love with the language, but because it was really the only language that I felt was suitable for my wants at the time, you know, and I was like, well, I could write it in C, but I want scopes. So, you know, I want private scopes. So
oh, that was Mark, that was the other thing that happened. The templates were coming around, but many of the compilers of that era had extremely poor template behavior. And so we picked the limits on the templates on the templates we were using because we could get reliable template performance.
Yeah, and templates are, you don't have to convince me. They're so powerful, but so awful.
Does it still generate separate code if you use like a hash table with like doubles and longs, even though they're the same size? That's kind of
that was part of the issue. Every different minor flavor got you at that era. Some of them, you know, a hash table from strings to structure X.
Yeah.
And a structure X was a pointer. So string to pointer. But every different type of pointer got a different hash table. And you just exploded your iCache. It just blew you out.
I guess it's what you got if you design a generics as a library and instead integrate it tightly with the language.
I mean, you could like manually hack it by like casting the types and having like one shared template thingy of the same size.
That lost. We could do that with void star polymorphism.
Yeah.
And that was, you know, lost the whole point.
Yeah, I took out templates just because of the bloats that you guys described. Like every little thing would just blow up everything.
Right. So
and with incomprehensible, you know, multi-page error messages, it took you to the wrong place.
Yeah,
I didn't even implement messages. I don't know what I would have done.
That's how C++ understands the generics. It doesn't have to be this way.
It has some flexibility. If you wanted to have like specialization for certain types, or you have like information that you wanted to flow through. For example, if you wanted to have your
if you want to reduce the generic, you always specialize it. Otherwise, how would you eliminate them?
What I never understood is that early on, it seems like the standards body was willing to accept everything, and except for a common name mangling format. And I hear people tell me that, you know, oh, well, you know, you need different name angling formats for innovation. I'm like, well, no, this is just a hack for the linker to work. So
that's weird.
You need different mangling formats so that you don't break backwards compatibility.
Yeah, to my understanding, this would have never counted. I mean, there were early proposals to standardize mangling names, but the ABIs would still differ. So you would still be passing structs by pointers or registers or stuff like that. And I mean, even the same architecture, x86 Windows versus x86 Cygwin, for example. So the standardization of the name mangling would never really buy anything in practice.
So we're still screwed no matter what. Cross compatibility is a lie.
Yep.
You know.
Well, write once, compile anywhere.
The issue for Hotspot was there is an OS portable layer as part of it, and that's the reason the Java runs everywhere. Is you paid the price once for every machine, for every CPU, for every OS.
Yeah,
that's just what it is.
So the JVM specification has to do a bunch of work because they care about dusty jars. I made this jar in 93, and now I want to run it in 2023, and that should work.
Yeah, although there's a bunch of extra work added for that. That was work that was done 20 years ago, and it still functions.
I mean, I would say the fact that they haven't broken old jars is because they've been very conscientious about not breaking old jars.
No,
have you used Java 9?
Yeah, there's testing.
Right.
And I wonder whether that would be easier if you said there isn't going to be an ABI. The API is everything, and I'm going to actually put some strings into the binary and say when the linker does its linking, it's going to look at those strings and say, what was the actual?
The class files, the jars, don't mention anything to do with any C ABI. They can call Java JRE code, the JRE has in the JVM got hooks into the C library. The JIT guy, he doesn't actually call C code ever internally directly. I mean, he might, well, he does. He doesn't emit code to call any C thing. I'm trying to think if that's true. I think that's actually still true.
I figured the type erasure would cause problems at the boundaries between jars. Is that not true?
So what would cause problems between boundaries between jars?
If you have type erasure and you don't exactly know what types get passed into a function.
Yeah, no difference. The JVM does bytecodes. The bytecode semantics have not changed. Type erasure just removes some type info that requires casting. You get a butt ton of casting. Casting became cheap, but you get casting. So the fact that you've erased the
so it's the fact that the cast can fail at runtime that saves you.
Yeah.
Is you try to cast a thing and it just goes, nope, I can't be cast that way. As opposed to C, where you try to cast the thing and it's like, whatever.
Yeah, he casts it, even though it's incorrect, and then woohoo, you're off into the weeds. Woo, no. Java, you can fail. And if it's one of those things where if I make a jar file that's been erased and I change who I'm linking against, who is originally linked against with somebody else, I can arrange for a situation where the jar files will come together, the loader will load it, you'll run, and you'll get the runtime error. Like if you do normal things, you can't get the runtime error. But if you start swapping jars out from each other, from their linking, compiling context and their execution context, you can totally get the jar to fail at runtime. And like for 20 years, I had a security hole in the JVM that I knew about where exactly I did this kind of a game. And I had to use a loader constraint where I did a compile the jar file under one loader constraint. I ran it under another loader constraint. And there was a bug in the JVM for testing the loader constraints properly, and you could make a string into you could edit a string, a final string later, after the fact kind of thing.
So in a language like AA, if I have a float and I say, I would like the hexadecimal representation of the exact bytes that is this float.
That's the Java equivalent of double raw bits to long.
Yeah, that's sort of my question. How do you get the double raw bits? Is that something that the language has to think about? Is that something that you use the serialization libraries for and hey, serialize this out as a
you call the double raw bits function?
It's an intrinsic. Anything that has to touch sort of custom hardware things under the hood, you're going to intrinsify. So you want a CAS instruction, there's going to be an intrinsic. But CAS has higher level semantics, so you put it in the language somehow.
And the intrinsics are not specified by the language. The intrinsics are specified by some language hardware.
The IEEE spec and 64-bit, 2-bit, 2's complement arithmetic are both extremely well understood specs. So the language includes the double raw to long because that semantic is completely understood. That's a language thing. And where you put it, it's in math, it's under double, it's under long, whatever. You put it somewhere funny, but someone can go get double raw bits to long.
Have any of you tried to implement BLAS into a language or a compiler?
I'm sorry, try to implement what? Splice?
BLAS, the basic linear algebra subprogram.
I have certainly made implementations that did BLAS-like things, and I'm not claiming I should port BLAS or claiming that I should replace BLAS. There's a good reason to call BLAS as an FFI. H2O never called BLAS, and we could beat BLAS on some specialized cases, but there were some things that BLAS did that were cool that our clients didn't really care about, so we never went that path. But yeah, you want some high performance computing things, and at some point you probably want to go FFI. Like we never did the fast Fourier transform hacks H2O, and so in those cases I had said, I'm just going to call the FFI library for fast Fourier transform hacks. There's, we did like Chomsky decomposition, matrix divide, ADMM for matrix multiply on giant data sets. That's the 3 math guys at Stanford. We talked with them once a month for a couple of years and got sort of the best of the best libraries baked in. We could do them in Java and have them run fast because Java on one-dimensional arrays would spit out code like a C or a Fortran compiler would. 2-dimensional and up, it wouldn't, but 1-dimensional it would. So you could get there. A different question would be, what's the 2D array layout story for AA or any language? And do you want to have Java's ragged arrays or not? And, you know, what's the difference? And the answer is, so there's interesting performance to be had by not being the ragged Java thing.
You could just do
and there's a lot to be said by letting people specify their memory layouts a little bit tighter. You know,
yeah.
Go, a lot of people gave grief and they're like, it's garbage collected, it'll never be fast. And they were like, right, but you can make a giant array of structs or struct of arrays. So if you can't handle the garbage collector in your tight loop, don't make garbage.
Oh, did you see the new proposal? They're actually looking to add like arenas into Go.
I saw that.
Yeah, my issue actually with I have a bit of an issue with this argument. So you often hear that you can just drop to the C style programming in Java, but the problem is that you don't get any support from the language and you don't get any support from the standard libraries in the language. For example, in C++ is this idiomatic, common, and frequent to take an allocator as an argument in your library. So if you just want to throw the entire application allocation strategy away and change everything and just recompile, you are good to go. And this is supported and this is common, this is documented, and every C++ programmer will know what you're doing. But if you try to hire standard regular Java programmer and tell them to program in C-style Java, you may be surprised at the outcome.
Yeah,
it depends on like what your hotspots look like, right? If you're localized, then it's not that hard. But if you're like need everything to be fast, then maybe Java is not the.
I know you can do it in Java, but I'm with Matt. There's no support.
Yeah.
So I do a lot of stupid looking shit in AA and in C2 back in the day. That was no language support, but here's what I wanted to do, and oh shit, it goes really fast when you do it this way.
I think the Java arrays are fine because if you want the layout you want, you can always fake it with the 1D thing anyway. So
exactly.
That's for most
what you just said was no language support for 2D.
Yeah.
So here's the other thing. Here's the other thing.
I mean, if you're using the libraries anyway, it doesn't look so bad at the use site level. It doesn't really matter.
Yeah, you have to wrap everything in an API that makes sense.
I think it's really funny though that people talk about performance and then do their logging over the network. Like,
oh god, that was the logging. Oh fuck.
So it's like, yeah, I'm writing this in assembly so I can put my log messages from my assembly over the wire and synchronously wait for them to get acknowledged.
Where I spend 90% of my time waiting for the disk to scribble bits that no one will ever read. Yeah.
And by the way, I'm not joking. I was looking up log APIs this week, and like there's now like 40 different, would-be standards for logging on REST. Like,
where's the XKCD comic on that one? Hey, there are 15
it's just like the joke we used to have with microservices and SOAP and crap like that, where you put together an XML document with a tag value1 2 slash value1 value 2 2 slash value 2. Okay, now send that to the addition service, so you can get the number 4 back.
Yes,
it's like you do realize you just spent like 600 million clock cycles to add 2 numbers.
Yes, and you got the wrong answer because the answer is 3.
Yeah. I don't know. The microservice craze came, and I was just like, okay, guys, you have added so much. The goal was to scale, so there was no overhead limit. But first, we're going to divide by 1 million as our overhead.
Not just divide by 1 million, but it's also because everything's stateless, right? Because the only hard thing about microservices is managing state. But what valuable things in the world actually have to deal with state? I mean, how many apps actually have a database behind them, right?
Jeez,
none. Yes. Nobody uses a database. Nobody stores stuff persistently.
None of my microservices point to the same database.
And you can see all this logic as well in language design, because the most important thing is factorial, followed by counting from 0, so every integer is 1 more than the number before it. And,
everyone can code FizzBuzz too.
I want to ask about
but go back for logging for a second. I have had more than one system that I was working on where we start digging in. We're like, okay, where is all the CPU going? Because we're at 80%.
Yeah,
and most of the CPU is going to converting Unix timestamps into human readable date timestamps.
Yes.
I want to turn my Unix time into ISO 8601, which means I need to load into memory the database that tells me when all of the leap seconds happen.
Yes. Yes. Been there, done that.
On the one hand, if you could just log the Unix timestamps and just use I to A in there, or actually log an int in binary format in there, that would be a lot more performant. And on the other hand, this is not a new problem because I forget the name of the device. They found a thing in a sunken ship that had a whole bunch of gears. That's the earliest thing of gears we've ever seen.
Antikythera.
Yeah, and it spends about a third of the gears calculating the motion of the planets and stars. And it spends about 2/3 of the gears formatting the date time so you can understand what it is. And they actually used more gears on the time stamp to tell you what day of the month it is, because some months had extra days.
Okay, how do you make that correlation?
Right, it told you when the next eclipse would be, which means it needed to know how many days were in which months.
It's a formatting issue.
I knew it had shit like divide by 17 baked into the gears and stuff.
How did they handle leap seconds?
Speaking of that whole topic, I think
wasn't invented then.
So in Inko, probably the most complex algorithm that I don't actually understand is the code that takes a Unix timestamp and breaks it down into year, month, day, hour, minute, second, sub-second, etc. Because I wanted to do this
next Easter Sunday. The math for doing the next Easter Sunday.
Right. Well, so
this is like
close enough. This like leap years and whatever, but basically, I wanted to do this without using any kind of system libraries, because you can kind of do it in C, but I believe then you get issues with like concurrency. Anyway, I didn't want to use C for it. And so the starting point that I used, I think, was the implementation of Muscle, where the C library, where their implementation of, I think it was get GM or get local time, whatever they call the function that does this. Their implementation was actually sane. If you look at the glibc, it's like, I don't know, a bazillion lines of code, doesn't make any sense. Whereas theirs was like 50. And didn't use any, 50 layers of macros, whatever. So I sort of ended up porting that, but it's the kind of algorithm where they use a lot of magic numbers. So you're like, yeah, I guess I'll just copy that. I don't know why they use this. But it works. But if you look at it, you're like, what in the actual F is this doing? I mean, it's not too bad, but there's a lot of stuff like, okay, we'll first subtract this, then we're going to divide by this random number, and then we'll subtract that. And now we suddenly have the day. You're like, okay. But it kind of works. It's kind of clever in the sense that their starting date is not 1970. It's like it was like January something 2001 or whatever it was. Anyway, somewhere in the early, kind of trying to read
That's
up, anyway, early 2000s, because it's a year where if you want to calculate
21st century.
I don't remember, but it was like some year where if you want to calculate leap years, the division is easier to start from that point.
If you don't cover my birthday, you're cheating.
Sorry?
So if you don't cover my birthday, you're cheating. You got to go back.
It can still go negative, of course, but it's just they picked a different date than 1970 because it's a little easier to do these calculations with leap years and all sorts of things. But that does make it kind of tricky to compare because they're basically the only one doing that. And I think it did have a bug there at some point, but it's fixed. But yeah, it's let me see how much code it is. It's it's only 20 lines of code. Okay. But it's a whole bunch of divisions, additions, multiplications. So you look at it, you're like, I don't understand what it does, but it works.
Yeah. Don't ask questions.
I wanted to know what you guys use memory arenas for, because typically I use them for the entire thread. So I was just wondering if you guys ever use it like not just for the entire thread.
Depends on the allocation patterns, right? So if you have some localized region where you can reset fast, then you can just you can even have multiple sub arenas.
But do you have an example of doing it yourself?
Yes. So hotspot
for home benchmarks, I have, but not like at work, of course. But yeah.
Okay, so hotspot would pile IR into one arena, and when periodically he would stop and copy the remaining live IR after optimizer was doing stuff into a second arena, and then free the first arena, and then he would go back. So over the course of a C2 compilation, he'd go back and forth 3 or 4 times between 2 arenas, basically doing a copy and garbage collection between the arenas. Copy compact, that was the right way to think about it, between arenas. So it's because I had a phase oriented, the compiler is phase oriented.
So was this only between phases?
I'm sorry, say again, between phases?
The compaction, the memory arenas were used at the end of each phase.
At the end of a phase, I would read the old phase's IR and copy it, compacting as I went, into the new phase's IR, a new phase. Yeah. And then
I've been trying to figure out how to work it into my language, but most of the time I just use it for threads. So it makes sense to do it on loops too, but I haven't done anything with memory arenas on loops.
I have.
But yeah, your example's good.
Okay, there's a lot of loopy things I do that are sort of easy. I think Ganesh is saying the same thing. You have a pattern where at the end of some point, you're going to loop back, you can reset quick and then go loop again. And that pattern happens all the time.
Another example is if you're like writing some like server that's serving requests, then if you know that your requests have some bounded memory footprint, then you can have an arena per request. Again, you have to handle cases where it doesn't fit in the arena, and then you can have any kind of various strategies for that. But
another issue is I find that sometimes when I have this problem, I would just use array.clear, like C++ can do it, obviously, but other languages might not. But then that just reuses the same memory.
Yeah.
So
yeah,
I'm still looking for more situations where I can use an arena.
So if you want things of different types in the arena, then that's a little bit more complicated, where you may not be able to just do it with the arena clear, right? Does that make sense? So
the example
like graph structures that have like limited lifespan, so you can contain that whole graph.
The example I think of is when I know things have different lifetimes. So working on websites, you often have this case where you have a bunch of work you have to do for a request.
Yeah.
And as soon as you return that request, that's all going to go away. So it may not be worth doing garbage collection at all because the request can't live long enough to consume too much memory anyway. And on the flip side, you have a big cache, and you want to make sure that that cache is always warm so that you're not pulling a lot of stuff out of the database. So the arena trick that we ended up using was we kept the cache in memcached running on the same node as the web server. And we had Python configured in a don't even bother doing garbage collection mode. And then each time a new request would come in, Python would fork. And if you had garbage collection on, the garbage collector would touch all the memory and it would copy on write, and the OS would make all these new pages that we didn't want it to make, because for the most part, it was never changing. But if we just turned the garbage collector off, the mark and sweep garbage collector wouldn't mark all the pages and make the copy on write copy all the memory. And
That's
then
clever.
As soon as we finished the request, you could kill that copy of the VM. And the next time a request came in, you could fork again. Basically, this whole mess was because we didn't have a way to say, put all of this stuff for this request in an arena. What I really want is an arena that is maybe even a garbage collected arena, but all the arena stuff happens over there. And I want we got our web server to the point it was ready to request something, and here's our giant cache of stuff on the side should be in like, here's the global arena, and here's our web cache arena that we clear some of the time, and then here's our per request arena that blows stuff away. But we ended up in this sort of nightmare construction because we didn't have any kind of concept of arenas in the language we were choosing.
I'm trying to say here, the moral of the story here is that the OS is a really nice garbage collector. When your process ends, the OS garbage collects it.
I mean, a process is an arena. That's kind of
for some of my early games, we did that. I just created a pool allocator, just allocated 4 gigs at the beginning. If I blew past that, then I did something wrong. And then at the end, if I didn't free at the end, the OS would free it.
Yeah. Yep.
A lot of databases work like that because they like pre-allocate the huge pages, so you need to like pre-reserve them on boot and a whole bunch of mess.
There's also this story that I saw somewhere, probably on Hacker News, about a missile that had all these memory leaks in it. It's like all that stuff. It's like, oh well,
John Carmack, I believe.
I don't care. When it lands, the ultimate garbage collection happens.
Right. It's only got to live for 10 minutes or less, and then it's garbage collected. Exactly.
Then it's certifiably garbage collected.
Yeah, I talked with hardware guys doing those kind of military work. And the other piece they could do is they could overclock the CPU really, really hard because it only had to live for 10 more minutes. And then as long as it didn't have, faults in the OS or the CPU faults for overclocking, they didn't care how hot it ran because done.
You've shortened the lifetime of the CPU by years.
Exactly.
For the processor, there is no time like the present.
Yeah, exactly. Yeah, that's a good one. Yeah.
Or for my language, because I'm going around the
it's still called, for the rest of time, it will be my language.
Yes, no, Minerva. Minerva, for what it's the way it works is you pass around allocators, and then I just have a macro system that's like, oh, okay, well, this global allocator, allocate to the global allocator, you're fine. And I was thinking for a long time, well, since I have a macro system, couldn't I just declare like a quote unquote new, and then I could have a thin mark sweep garbage collector underneath that people could use. And I'm like, that leads to some weird things in the library that I really don't feel like dealing with.
Well, your libraries either understand and deal with garbage collection or they don't.
It doesn't. So I was like, I don't.
Do you consider the standard library to be part of your language?
I'm still debating that. There's a lot of things that I'm thinking about just having a core part of the standard library, like file access, small things, but the rest I think.
Anthony, do you have some background noise going on?
Do I?
Yeah.
Somebody has, and so I'm about to go mute.
I believe it's direct, but okay.
Sorry, somebody's talking in the next room.
Yeah.
All right, good enough. Yes, I typically ask people to mute if you're not actively talking because background noise. Exactly. You just leave while you're fine.
But yeah, no, I don't know if I want it to be part of the language or not yet. It's up in the air.
I was just wondering, do any of you use the LLVM API?
I think Yorick tried to use it and then got scared. Or
Arthur, who's not on this call, but he's on every third call or something, uses it extensively to generate code for Java instead of C2.
Yeah. Okay, so everyone tells me that Clang and LLVM are single-threaded. And when you're talking about the OS being the ultimate garbage collector, it's also the ultimate thread creator because I can create 4 processes of Clang, then just compile them all asynchronously. And it works. I got 500,000 out of it.
Yeah. I mean, parallel make, pmake. Many a project I worked on has used pmake.
I've tried using LLVM. I
don't
really do not like its API. I don't like the fact I have to rebuild my backend sometimes when I run brew upgrade. And just like I'm like, you know what?
Keeping a stable API is also hard for them, I think. Like prevent certain kinds of evolution.
I get that.
Yeah.
But at the same time, I also really like Scala. But sometimes when Scala does a major version break, at work we had to spend what felt like months, probably wasn't months, rewriting the entire world. And we started missing Java at that point and slowly started converting back to Java. So like my point is, like, yes, you need to have certain momentum in order to keep the language running, or to make your system good, to make your system go forward. But at the same time, if you make it so painful and you're not in the giant mono repo where you're able to change the world at a whim, life starts getting really difficult.
What's actually nice is the CLang or the LLVM IR doesn't change. So I just produce it once and it just works. Like I've never had to retool my compiler. It just works. It's great. When I looked at the API, however, I'm like, this is just far too complicated. And I don't even know what kind of speed I would get if I went directly to the API. But I figure that yeah, the text IR is like, it's pretty fast. So I had no issue with it.
One of my goals with AA was, I hear a lot of people screaming about having a setup or a system that has a JIT baked in with a runtime and garbage collection, all the right hooks that they could build their own language over. And I've done all those low-level parts in an integrated, system, but that's all buried under the Java piece. So I'm going to get an open source version that was actually intended to be picked up and hacked on, including the JIT, including the hooks for the GC and the threading, all that kind of stuff. Long-term goals, future talk.
Ironically, I had this same thought because I was working on a back in the Minecraft modding community. I was working with somebody on a language called Joe. We called it Joe because it was just Java, but we called it Java without the ceremony. And we were just wishing that there were times where we were wishing where we could just access some of the JVM, do some JVM stuff without needing to actually hook back into the Java language. Because unless you're hooking into the Java language, you are significantly just hindering yourself with doing anything on the JVM.
Did you try generating the bytecode directly?
No, we generated the bytecode directly, but it's like file access. We can't. Didn't want to do all the native stuff for that.
That you call because you're generating bytecode, you just generate the calls to the Java runtime.
So we wanted it without the Java. We wanted to basically have like a VM that was straight opcodes where we didn't even have a runtime, the RT jar or something.
Let's say, yeah, but you're grabbing you didn't want to grab the RT.
Yeah.
Okay. Well, then yeah, and then you're tough.
So what about WebAssembly? Have you looked into that one? I don't particularly like it, but it seems fine.
WebAssembly seems interesting. Like I've seen emulators written, emulators written, so that way you can run a full Linux a full Linux OS in the browser, which is interesting. But people also put Linux into pixel shaders, so
What? It's hilarious.
Well, anytime a new hardware comes out, it's either Doom or Linux.
Yes. Plenty of them Doom ports floating around. All right, we're slowing down here. I'm gonna pick something new topic, or I'm gonna be done.
I can talk a little bit about the hash tables, but
what'd you do with hash tables?
Is interested.
Yeah, fire away.
I just did a lot of small prototyping, and one thing that surprised me was I don't know if anyone tried to do this, but I tried to, instead of copying to a new table, I tried to incrementally copy. When I resize a table, I just incrementally copy some stuff over, and that code ended up being the most difficult part. And one thing that surprised me was when I got to the edge, I would just roll back to 0. But you actually have to fork in that situation, because you might have there was like some situation where I had to look at 0 because my data might have been there, but it also might have been at +1, like one more than the previous size, because I had different blocks. But anyway,
is it a concurrent hash table or single thread? Or
non-binding hash map does the table roll, incremental table copy to the larger table or smaller table.
Yeah, well, what I did was
a full table copy can be a really long pause.
Yeah, I had an
it's
option where I
incremental.
can double or quadruple the size. So at the points from if you go to the if the index is exactly the old size, I would loop around back to 0. But in that situation, I still might have some data at the index.
Yeah.
So it was just really weird. So I tried that. I tried a few other things, and then it turned out to be like just copy the entire table right when I want to grow is the fastest way to do it.
Okay, you shouldn't be mixing indices from the old and new tables.
Yeah.
Well, I wrote the code for it and I tried it out, and yeah.
So
I found the same thing though. It's faster to do it all at once, but the latency spikes on that operation.
Right.
So the reason you do it incrementally isn't because it's faster; it's because it smooths the.
It's smooth. Yeah, non-blocking hash map has a knob I turn. It's been at 16 for years. Each toucher moves 16 elements and then does his thing. And when the table's done, and then the table gets done, as long as somebody keeps touching the table gets done, and you finish the promotion, and then people quit doing the promotion check.
Does it care what the size of the elements are?
It's in Java, right? So it's
the elements have to be movable in an atomic word. Like non-blocking hash map, long and hash map, they move an atomic word.
So it's not I move an entire cache line.
No, because there's no, you actually don't get an atomic guarantee. Actually, on Intel you could, but you wouldn't on other chips maybe. But there's no API in the Java unsafe to do the 128-bit cache.
Yeah, but you're just working with the references, so you're not actually moving. The objects sit where they sit.
Yes.
So I'm looking at the numbers, and I noticed that it seems to be 3 times longer to incrementally update than it is to just do it all at once. Like 3 times longer to grow, and growing is actually the slowest part. Yeah, that would actually like surprise me. So I've been prototyping like a piece of the hash table at a time to see which variant is better, and just trying to figure out like the best way to do it.
It depends on which metrics you care about, right? So like Cameron said, if you care about like per operation latency, then you want this incremental growth thing. If you care about the like total throughput, then you may want.
It's also 3 times slower, so I don't know.
But you may have something else going on.
What? Yeah.
Consistently 3 times slower seems unusual, because non-blocking is not 3 times slower during the copy. It's like 20%.
It just might be the way that I implemented the way I did it, because it wasn't using 2 table. It was in place incremental update.
Okay.
Another thing I noticed was I compared with
get a larger table in place.
Oh, I just use a realloc.
And then how is that guaranteed in place?
So when I well, I think I gotta like explain what I mean by in place.
Okay.
Like I just did a realloc, so some of the data is still in the table.
Yeah.
And then I when I grow, I mark it as 1 or -1. This time around I did 1.
When you
and
say
then I just check for it.
What are you marking?
So the new data is all set to 1 instead of 0. So when I see
what is 1 or 0? Because my data is not 1s or 0s. So what you're marking some sort of bit.
Oh, the keys.
The keys. Okay, can I have 0 keys or 1 keys?
Yes, but there's also a little hack I have to do for that situation. But yes, you can have them.
Okay.
So when I do the realloc, all the new keys are set to 1. When I see a 1, I know I have to execute my code to pull out the data from the old indexes, and that's how I grew it. And maybe it's just the way I did that is slow, because it's 3 times longer to incrementally do the entire table versus doing all of it at once. I also compared against C++'s unsorted, or I forget what it's called, the unsorted map. It actually was really fast to grow. I thought it would be as slow, but it was almost twice as fast. But table lookups are slower, so as long as I'm looking up data, it's my hash table is faster. But if I'm just writing data into it, I thought it would be roughly the same speed, but it turns out they're twice as fast for whatever reason.
I have a set of slides for non-blocking hash map, which you might be interested in. I'm going to see if I have a newer version, but I think I don't. Let me.
This is just for prototype, just to see like if it actually was faster to do it one way versus another.
Well,
I probably would end up doing the way you suggested it the other day.
You're comparing non-blocking hash map to unordered map? I wouldn't think those things are.
Non-blocking hash maps as fast as almost everybody's good, fast, single-threaded hash table. Yes. I've had it tested by many folks as being like as fast as your good, fast, single-threaded hash tables. It's fast. And that's because it's this damn state machine thing. So it is a general purpose. So you can have special purpose hash tables that'll beat it in the special case situations. Let me throw a link in here.
Cache if you're not terribly contested, right? You want to do something.
That's right. I'm confused how you can even compare, like unordered map isn't thread safe, right? This is like massive advantage.
So if I, that's the point. There's not.
Unordered map.
If I take a billion entries and I throw them into a non-blocking hash table, or I throw them into an unordered map, and I do 50-50 read-write ratios, 90%, 1% read-write ratios. I do all kinds of things, but it's all single-threaded. Non-blocking hash map always comes really close to all the good single-threaded fast guys, typically beating most implementations, but some people got a good job done, and then I don't beat everybody, but I beat a lot of them. And this was tested by a lot of folks, including some public ones done by Jerry Manson at Google, where he tested all kinds of shit. Non-blocking hash maps fast. And that's because
when you publish into the cells, I guess you're skipping a volatile, right? You're doing like a put ordered or something.
No, I do a classic CAS. Some volatiles are involved, and there's a classic CAS to put something into a table slide. That is the major cost.
I'm amazed that you're able to match the things that don't have to deal with.
CAS on a cache line that's not contested is 10 clocks instead of the 2 or 3 for a normal store. So it's not a huge thing. You have to hash, you have to probe, you have to mod, you have to run the key compare. All that shit adds up. Then the CAS, there's only the one, and then the CAS is not so expensive compared to everything else.
Do you have any risk of starving out a slow operation?
It's only if your hardware starves people who fight over CAS. If your 24-core Intel chip, all CAS is on the same line, trying to update the same word continuously, and if the hardware starves, then you'll starve.
There's no hardware guarantee of anti-starvation, though, right? As far as I know.
No.
There's no hardware guarantee of what distribution?
No. So the hardware doesn't guarantee that everyone gets a fair chance. That's why you have
the Azul hardware did. The x86 doesn't. If everyone wants to update the same word, right, and you're going to still be race safe, but they're all updating the same exact word, you're going to get limited by generally the speed of ping pong between CPUs.
If you want fairness, you should use like manually queued locks and then like MCS.
Well, only if everyone's updating the same word. I mean, it's just a really rare, odd situation. Everyone reads the same word. There's no CAS involved. There's no volatile involved. It's all straight up read a cache line. It's all cache locally.
Right.
It's all one.
But if you've got 8 writers who are constantly writing to the same key, you're probably better off doing something that's striped.
No, it doesn't work.
If you're writing to the same key, you're screwed no matter what.
You're screwed no matter what. Yeah. And Aaron, your video just locked out. Okay, wait, back up. So Aaron, your video locked out for 30 seconds.
If I'm in the case where I have really aggressive writers and relatively little reading, I'm better off doing something that is striped. And I have each person writing into their own memory address. And then when you read, you have to read all 8 memory addresses and pick the one that has the latest timestamp.
Okay, so non-blocking hash map does striping if you have unrelated keys. If you have related keys, your hack does not work because there's no timestamp that works on an x86 of certain revs.
It's interesting though. You're describing the concurrent queue in ecstasy. The concurrent hash map in ecstasy. Since everything ends up being over a queue to push updates to it.
Right. If you have the latest versions of x86s, you can use the count register to get an atomic timestamp, but that's a much more expensive operation than what you're getting out of non-blocking hash map typically. Now the size counts are totally striped that way. In fact I taught Doug Lee that trick. The concurrent adder does striped adds specifically so that you don't get contention on those. You should try it.
Funny thing,
it's a standard straight up hash table. It's complete.
That's funny. I think I heard that from Doug Lee. Or from a Doug Lee.
Is this the JC Tools project?
Yeah, that's where it ends up now. I mean, I have my own private repos and I hack it occasionally, but JC Tools has a reasonable version. Yeah.
Okay.
So what's funny is a lot of hash tables are tiny. So hashing is the most expensive thing that they do. In the table part, they'd be better off with a sequential scan through an array.
Yes. Non-blocking hash map starts with a tiny table because it's basically doing a linear scan until your table gets big.
Yeah, I've been wanting to test how big a table should be before it's better to just use an array and scan it linearly. I haven't gone around to that, but I did test
it's
3
not as
different
easy as it
algorithms.
sounds. It's not as easy as it sounds because you have two different things you have to do. You have to hash and you have to compare, and you may have to compare multiple times. So it's like there's this.
If your compare is expensive, you don't want to grab a cache line and test everybody on it, because the hash will give you the one guy who will probably win, and you only compare once.
So if your compare is expensive, then you want to spend more time on your hash, add a bunch of buckets you're not going to use, and use a prime modulo. If your
prime modulo is unrelated here, Cameron, just unrelated. You have to have a better hash function, which does not necessarily mean anything about primes.
So I tried using a SIP, XX hash, and murmur. It turns out that all 3 of them give very, very low collisions. I think at XX hash I found one actual collision, like an actual hash collision on a 32-bit integer. But I noticed XX hash was like the really, really fast.
So I use
murmur was quite good as well.
I use this thing from this guy called burble.net. It's in my code. He has a nice write-up of why his shit works. It's a handful of clock cycles on an x86 because it all parallel issues, rotates and zors and shifts and shit. And he does a really good spread job. But yeah, getting a good hash function is as important as anything else. So in case if you're busy testing like tons and tons, I stuck a billion stupid Java strings into a stupid Java array, and I'm looking up, well, your hash function sucks because the Java string hash function sucks. Not you, but whatever. And that's your problem, as opposed to necessarily the implementation of the hash table. So
I still got to tackle.
It kind of amazes me that we're still getting better at hash functions that are less than 10 clocks. Yeah, I would have thought that humanity would have just like found the best one by now. But
let me pull up burble.net. It's a good one.
There's a link I just posted in the Zoom chat. You can like use the AVX or like the AES intrinsics to get good hashing. And then the newer ARM chips, those are like 3 clock latency. So pretty nice.
I forget what it said, but something like XX hash is like faster than memcopy. I forget why it's faster, but yeah, it's fast.
It's because memcopy has to deal with a bunch of border conditions on the chance that part of the address overlaps the other part of the address.
That's memory.
And it has to write.
There we go.
The third version, the copy part of memcopy is expensive.
Yeah. Yeah. Actually, yeah, hash only has to read. It doesn't have to write. That helps.
Maybe it was actually comparing the speed of memcopy on L1 or L2, but yeah, they showed some benchmark and XX hash was faster, and I thought it was just pretty funny.
The later
some guy actually made a fizz buzz in assembly, and it did like many gigs per second. It was pretty hilarious.
Ratios.
The latest version of the XS3 is I don't know how they make that fast, but it's faster than a sequential run rate, as I said. The third version of the XS hash. It's clocking something. The sequential read is clocking at 28 gigabytes a second. The 128 version of the XS using SSC2 is 29 gigs, and the hash
that's what I'm
rate
using.
31 gigs a second.
Okay, but how many bytes of hash are you hashing per entry lookup? Like the usual stories I look at.
XS 128 hashes 128 bytes at once. The width.
Yeah, no, that's what I'm saying. When I'm looking at my hash tables that I use in sort of recent memory, there's a virtual call to go compute a hash. That's some overhead. The hash guy looks at a dozen things or less, 4 or 5 things to get some bits. He throws them to a mixer, like I'm using this Bertle guy, but what do you sick or murmur? When you throw in a mix, that's your hash. You didn't look at 128 bits or 256 or whatever. You looked at a very small count of things, but kind of smeared about from hither and yon. and I'm currently in AA. I'm currently tracking a 64-bit hash because it's the same cost as a 32-bit hash for slightly better hashing, but it's only slightly better. So I mean, if my goal was to do a cryptographically secure hash over a large file, then I care about gigs per second. But
there are hash tables that are using SIMD for lookup, so you go through 4 items at a time, for example.
That makes sense. Your hashes are all in an array, and you're going to compare 4 sets of hashes all in a go. That makes a lot of sense.
I don't understand how to use that.
Thing that I posted, it basically has that they have like a separate metadata region where they store like densely packed like 8-bit hashes or like 6-bit hashes and then use them.
Oh, they use a special smaller hash as a pre-filter.
Yeah. So they have like that like pre-filters you while keeping the metadata hot, and so depending on.
Well, there's hash typically, then there's your keys you have to call the compare on, and you do the equal, and then you do the deep compare.
Yeah.
There are some databases that you are using something like that for hash join. So when you implement hash join in the database for the SQL query, you often can use the hash table for that join. And you can use a site table like a Bloom filter. So you will not even have to look up for the items in the hash table. And that actually gets you some really good results. Yeah. You just by just avoiding looking at the hash table.
Yeah. I did SQL query hacks for that database company. I was doing H2O SQL query, and a lot of them were joins that were hash table joins. And non-blocking hash map for the win for concurrent lookups, but you did Bloom filters and you did whatever. I did Bloom filters, and then I did big hash tables with millions and millions of things in them, all with typically very short keys. Whatever SQL query does for keys for those things.
I'm still thinking about like how to get SIMD working with the hash tables, because usually the first guy is like the result I'm looking for. So it doesn't really make sense to use a hash. I was also thinking maybe I can
to make sense to use SIMD.
Yeah, SIMD. So I was also thinking maybe I can check the first guy with a regular if statement, and then after that load the rest with SIMD.
You get a cache line. You paid for a cache line, so now after the first if fails, do some sort of SIMD operation for the rest of the cache line.
Yeah, but I also remember that most of the time SIMD it takes quite a few cycles for it to load the memory. So you're better off doing 2 loads at once, and that's 64 bytes already. Plus the if I did, so that's I'm crossing a byte cache line. So I don't know how good of idea it is to do SIMD, and I also would have to figure out how to separate the values from the keys, but keep them close enough that I don't have to pay too much of a cost. And I haven't looked into that with my prototype.
Really depends on a wide variety of things, right? One is like the compare cost, also the key and the value sizes, and also are you looking up keys that are usually in the table or not in the table, and the density of your access patterns, and all that would determine whichever idea.
Yeah, I figure the code I'm using that I wrote in right now is usable, so I'm going to keep that for the moment. But I still think about the SIMD sometimes because it's fun.
Yeah.
The approach I would go is to leave the hash map as an interface and leave all the smart guys to figure out faster hash functions and faster functionality that you can reuse at this stage.
Well, the theme of my language is being really fast, so I got to compete with C.
So you have to, at this point, you have to compete with the other HashMap competitors for performance.
Yeah, right now I can beat unordered map, but I still kind of want to beat it more.
A lot of folks claim they're beating unordered map.
Unordered map.
Yeah, I'm not even 100% sure. Actually,
right? So it's not all that difficult to beat depending on the workload. Try to look at like the more like dense, like the linear probing tables you haven't compared against those.
Yeah, I got to check more cases because I only did a 32-bit int with a 64-bit pointer.
Yes.
Yeah, I gotta try more.
Yes, do more versions of
there is a bunch of open source benchmarks for C++ hash tables, so I would just try using those. They already compare the fastest hash tables, so you can see how you fare against those.
Yeah.
I'm missing my last go round for good presentation for hash table for non-blocking hash map. Damn it.
There's a
I'm
YouTube
not going to
video
support
from,
threads for a long time.
what's the presentation you gave to Google, like from like 2006 or 7 or something?
Yeah, right. I have that version, and I swear I have a newer version, and I am looking for it and not finding it. So I
You
have
don't have best practices that you like for how to test how long short operations take. It's often kind of difficult to benchmark things that are happening in, 10, 20 cycles.
in the land of Java, it's what the hell is it called? The Java
DMH or something.
Yeah, there's a project that went around. JMH. Yes, I fought this fight for a long time because I was always fighting against C code guys, and they all had the wrong thing. And so JMH, if I'm doing it sort of quick and dirty, I just grab nanotime and average a bunch of nanotimes. Throw out
as in take nanotime, do the thing, take nanotime again.
No. But don't do that. Just use JMH.
Yeah.
There is a good reason to use JMH. I know what I'm doing. I can make myself get reliable numbers. I have a warm-up period. I do all the right things.
Yeah, JMH is mostly about undoing all of Cliff's work so that it doesn't make your code disappear.
Yeah, and then I make sure my
so
code
you're actually measuring what you think you're measuring.
Yeah. That's the other.
But it also makes it really easy to write those micro benchmarks. Like, they can become one-liners.
So usually I'm doing this inside the context of another large project where here I want to know, should I be doing X or Y, but I want to get here with a large complicated thing. And so I'm picking between a couple of different versions, and that's why I'm doing it on the spot. But if I knew I had a micro benchmark, I'm just going to do up front. Yeah, I just got it.
It's super easy to
What if you wanted to do something very wide, like count the number of times each function in your code was called during the run of your test?
Are you multi-threaded or single-threaded? Makes a difference.
Oh, but the answer then is async profiler.
Okay, maybe.
And if you're really interested in learning how to not write benchmarks, just look at the computer language benchmarks game.
Okay.
Oh God.
I don't want to touch that.
I was just thinking things like if my
things,
function got inlined away entirely,
yeah,
but the function that it got inlined into had some count, I want to add however many times that function got called my function.
In the land of Java, but it's a C too. If you're single threaded, you just put a counter in, and an x86 will do the counter really efficiently. If you have a large, fancy, complicated control flow thing, you can do some of the old Bell Laris optimization of where you put your counters. But if you're just like, hey, how many times this thing? Put a fucking counter in. If you're single threaded. If you're multi-threaded, you want to do something a little different.
And then you just have some stats endpoint that like checks those counters once a minute or once every 10 minutes and sends them off to whatever your stat collector thing.
I usually actually, when the counter hits some power of 2 that I dial a knob on, I print the count power of 2. So I set it for, say, 1024, and I say when and mask with 1023 is 0, print the current counter value. And,
have any of you used read timestamp in production?
I don't know what that is.
I think he's referring to the
if you grab timestamp,
the counter.
Yeah, there is an instruction RDTSC.
RDTSC, right.
It has a lot of caveats you have to be aware of. You may have to serialize it. You may have to use something like RDTSCP. We may have to use CPUID at the end, or you may use elephants, depending on the overhead. I mean, if you're timing micro-architectural events, like you want to see which AVX512 instruction is faster, which is something I do, then actually you have to be very, very careful how you time this.
I actually found a macros in the internet which neatly summarizes to appropriate.
I never seen it used in production. Either of those, either of the timestamps instructions.
I mean, depends on what you mean in production, because I mean, the way I use it, for example, is to compare the instruction the compiler is going to emit. And I write my own benchmark and I measure this and I have the result and I choose the instruction. And that's it. I mean, it's not as if I'm going to put the timing harness in the compiler, right? So
plenty of timing harness effects in the profiling built-in hotspot, and those are in production all the time. So there's some care made to get good, accurate times out, but one of them is RDST and nanotimes was unreliable up until recent memory, and now it's reliable, but you still want to know that you're not flipped between OS threads, so it runs backwards, so you want to check for negative. Milliseconds is probably takes 10 nanos to compute and is otherwise very, very accurate if you're at that scale of events. So most folks just use millitimes in the land of Java, and those are on in production all the time. I said nanos, 10 nanos is probably 50 nanos. It has to do with how to read some Linux kernel piece that gives you a current timestamp, and then you do.
It varies quite a bit by hardware and OS too. Like both that and the read TSC, like they can get up into the tens of micros.
A read TSC so on a bare, not a VM, on a bare metal.
Yeah.
It's just like on an Intel from 2010, because you have to do the that's what Matt was talking about. You have to sync across the cores.
Right. I knew it was ugly at some point, and then you know Intel said use this, and we were like, yeah, but it sucks. Then
I found the macros. If someone can paste it.
We'll fix it going backwards and forwards and being non-monotonically increasing by making it 100 times slower. So you had to not use it when you were running on a virtual machine. And then we got TSC was pretty sane, I thought, in the last 5 or 6 years.
The recent stuff I did on ARM, I thought was around 20 nanos.
On ARM
for both.
But that's okay.
Yeah, I don't have any recent. A year or two ago, I saw tens of micros on Intel, but that was on Mac OS, which is questionable.
Okay, but I said, were they intercepting it with a virtual machine? Because that'll kill you.
No, it wasn't a virtual machine, but I think there was an issue in Mac OS. But I think that's been resolved now.
Okay,
but I don't know. Basically, I get like I'm scared anytime anything reads the clock. Like it's for my entire life. That's been this could be horrific or it could be fine.
We actually had some disaster at work when some like Linux version it used like too small thresholds for the TSC watchdog timer, so it like spuriously fell back to HPAT, and that like a disaster because it's like a global.
The route I go now is I always have a single background thread that wakes up every 10 millis, reads the time, stores it, and everyone else just reads that stored time, which costs like 1/3 of a nano.
Right.
If you're okay with the resolution you get on there, that's good enough.
Yeah, well, if you measure enough samples, that ends up being meaningful. But it's just it costs. I don't know. It's too risky to actually read the accurate.
So Matt points out that in the newer chips, the read TSC is reordered because it's a normal instruction with your other instructions. And because it's reordered, then it just blew like I'm counting cache misses. This L2 is probabilistically, statistically sometimes load hits an L2 or it doesn't.
Yeah, I mean, if you have RDTSC, a bunch of code, and RDTSC, then those two RDTSCs may be reordered to execute before your bunch of code, and then you're gonna have zero latency, but that's probably not very latency you're measuring.
It's not.
Is CPU ID the easiest way to synchronize it?
Yeah, it's very expensive.
Elephants. Read this blog post, but elephants is the way to go for a large set of measurements. But there are recommendations at the end of this post, and I would agree with these.
Usually you should time larger sections so that
unless you are comparing literally one instruction versus another instruction, then you may have no choice. There is also a way to use cycle by cycle events in the newer Intel chips. You have more precise ways to measure, for example, at each cycle.
Are they user mode?
depends. Some are user modes, some you may have to write to sudo once to reprogram them. But I think most of them are user mode. There's even many that are virtualized, which means they will work with the cloud on a VM, which is also useful. But that depends on a counter by counter basis.
Here's the new version. Okay, I found the new version. Oh no, damn it, I did not. I found the H2 distributed key value store, not the non-blocking. Never mind. Sorry, interrupt for no reason. All right, I have a decent copy of non-blocking hash maps, hash table, if especially Mark, if you're thinking why is it so fast, if you were curious, but otherwise we can blow it off.
I am curious. I do intend to at some point dig in there.
Okay. Well, I threw it in the docs, in the Google Docs link. And there is a Google Tech Talk where I explain all this to the Google groups. So, all right, we're at noon. It's 2 hours. I'm going to, unless closing comments from anybody, and then we'll call it done.
Thank you.
A thank you meeting. It's lunchtime. Well, I don't know where Aaron is, but aren't you California?
Yeah, I'm in Redwood City.
Yeah. Okay. Yeah. All right.
Hey,
Big silence. So, I'm going to declare victory.
Okay, guys. Next time.
So next time. Bye-bye.
See you guys.
Bye.